Right, so I promised that this lecture would be shorter than the previous one. Thank you for staying here. Yeah, so it's already a bit late. So during the previous lecture, we discussed the first stage of working with a text. We discussed the pre-processing stage. Now, within lecture 8, we will discuss a few ways of text analysis. But before that, we will get acquainted with a few things which are normally mentioned in the sphere of natural language processing, although probably you won't use all of them now for your project. So we will discuss the main libraries that are used for text analysis and for machine learning. And then we will discuss frameworks which are used again for machine learning. Although machine learning itself is not the part of our course today, but if you get into it, then probably next semester you will take a course on machine learning and then you will come back to those frameworks. Finally, we will discuss with you 3 ways of text analytics, text analysis, that I suggest that you can use within your projects. So first of all, probably to evolve your pre-processing text, pre-processed text, you will do some part of speech tagging and named entity recognition. And then you will do either of those 3 things or all of them together. LDA is to figure out the topics of the corpus. So this is the method for topic modeling. Then sentiment analysis that I mentioned on the previous lecture to analyze positive and negative attitudes towards some tendencies in your research. And finally, the third thing that you can do to proceed that text analysis, you can do some clustering tasks to deal with the documents within your corpus. So let's discuss it step by step. And the first thing is that we need to differentiate between libraries that can be used for machine learning and for text analytics and frameworks. Anyway, most of them, if they are open ones, they are available through so-called application programming interface. And normally we get those API on GitHub, which is a resource, a web-based platform where teams work together on different projects. And so if the repository of a project is open, then any one of us can copy parts of the code and also read the documents and sometimes use the corpora that are available. For example, as for the Russian language, still the most popular corpora is Deep Pavlov, and if you need to, for example, launch a bot or whatever, you can use such repositories with corpora as data sets for your tasks, if they are open. As for libraries, the most frequently used are pandas and NumPy. They are used normally together, and they are designed to process some easy tasks with data frames, and we will in a minute look at how they work and what is the difference between them. Although, as I've mentioned, they are normally used together. As for frameworks, they are used not for text analytics, but for machine learning itself. And normally you choose one of those frameworks. In fact, within our project, we will also use scikit-learn, sklearn framework. But as for applications, different they normally choose between TensorFlow or PyTorch, and also we will now discuss with you the differences between them. In general, this is how it works. So normally you call the library when you need to do something with your data set, and then the framework calls your data set, calls your code to process your data. That's how they work together, libraries and frameworks, in machine learning tasks, and sometimes in rather deep analysis, text analysis. So let's look in more detail at those mentioned libraries and frameworks. So as for pandas, this is the most widely used open source library for text analysis. This is the easiest one. It is imported as PD, normally pandas as PD. And here we have an easy data set. Would you remind me, does it look like a list or a dictionary? Dictionary, sure. Why so?
Because it has key and class, and then a list of which in this situation is a value.
Absolutely, yeah. So it has the keys and the values. Yeah, they are the list for sure. Yeah. So if we take, if we have this one, here is the list, sure. Here we have the examples to differentiate between them. And all that together, this data set might be processed as a data frame. So first of all, if we ask just to print this data frame, we will get something very similar just to a table. With pandas, we can, of course, assess just a column. For example, if we assess the column age, we will get this result. And if we filter according to the column, that would be the next result. Here it is. Yeah, so according to the age, we would get just this item. And finally, we can also group something within this data set. For example, if we group by city, by one of the variables, one of the keys, then we get how many results we have with each city. In fact, all those tasks can be processed with SQL language as well, which is not part of our course, but still also used in natural language processing task in machine learning. However, I would say that with not very huge data sets, pandas are enough to process. NumPy is considered to be a bit more complex and powerful because it deals with numerical operations in Python. So if we deal with some data frames where we need to operate some mathematical issues, then probably we would, in addition to pandas, import NumPy as NP. Here we have another dictionary, another data set where the key has the list of values. And it deals with the results of exams in two subjects, history and geography, for 3 students. So let us first, with pandas again, just print the students. Here they are. So here are the results per each subject. Then we have the task to score them totally. And here we have already as an output their kind of rating according to their total score in 2 subjects. So the easiest operation. A bit more sophisticated is the operation of figuring out the mean score that they have, and again the mean score in terms of those 2 subjects. In terms of history here, I'm sorry, grouped by the history results with the mean score. Of course, these are just basic operations, but as you see, if we just need to figure out something from our data set, pandas are enough. If we need to analyze the data that we have in kind of a huge table, then we need NumPy to process different operations. This was about libraries. Now let's go on with frameworks, which are normally used for machine learning and deep learning. So the basic one is scikit-learn, sklearn, which in fact you have already tried out during the third lecture when we discussed with you different vectorization techniques. So would you remind me of what vectorization techniques do you remember after a month, so to say, from that lecture? Do you remember anything about vectorization? Because TF-IDF is one of the techniques, and in fact we use the framework sklearn to run it. So what is vectorization, and do you remember any vectorization techniques? The basics of it. Uh-huh. Uh-huh. Okay. Word to vec was a very good keyword here. So in fact, the basic vectorization technique is bag of words. Remember? So why is it called bag of words? What does it help us to figure out in the corpus? Just are they used in the corpus? So kind of is that word in the bag or not? Word to vec in its turn uses a continuous bag of words as an opposition to skip gram, where in continuous bag of words we can figure out which word is used after the word that we are searching for, and on the other hand, on the opposite, skipping gram, we can, relying on the context, fill in the gaps. Yeah, do the task of filling the gaps, find a word that is needed, for example, in the dialogue with a bot. Another these are the vectorization techniques. So bag of words is too easy. TF-IDF is a bit more complicated because it shows us the score, the number of cases of the terms used in the document matrix. Yeah, so term frequency, document frequency. So it shows us how often a particular word is used in the set of documents of our corpus. And in fact, modern transformers, they are based not of bag of words, of course, but on this term document matrix. And sklearn is one of the frameworks to process it. So let us have a look what can be done with it. So here again, NumPy and pandas are imported. And then sklearn is used for classification tasks. In fact, basically, if we speak about natural language processing, two basic tasks, two fundamental tasks are classification and named entity recognition. So if we deal just with easy classification, normally sklearn is used, sklearn framework, because it helps us, for example, to launch a bot and to classify all the utterances this or that way. So here we have a particular data set, doesn't matter which one, and then within the data set, different parts, different documents are weighted and classified to this or that type of the document, which comes from the first column. So with easy bots, normally this classification task is quite enough. So if it classifies your first word hello as a greeting, it would choose something which suits the answer to this type of utterance. On the other hand, the more sophisticated task is named entity recognition, when you work with particular words, and we will come back to it in a few minutes. So sklearn is the easiest framework which is used for classification tasks mainly. As for more sophisticated tasks such as named entity recognition in machine learning, then PyTorch or TensorFlow can be used as a framework. In fact, according to the statistics, for most cases, they use PyTorch and TensorFlow like 50-50. Although they have some huge differences, PyTorch is easier for sure, is an easier tool for machine learning. So it is used more often for research purposes. So if you take the next step after this course and try to go deeper into machine learning, probably you would start with PyTorch. TensorFlow is a bit more difficult and complicated to use, to utilize. It's not so flexible like PyTorch. However, of course, the results of the performance are kind of better, and it can be used in some hard tasks, especially with some mathematical operations. So that was again kind of introduction. Like the previous class we had introduction to Python, here was kind of an introduction to libraries and frameworks that you might come across looking through some materials on natural language processing and machine learning. Let's now deal with text analytics, which is our task and which is the thing not for further research for you, but for your project. So first of all, obviously, you would do some part of speech tagging and named entity recognition task. So part of speech tagging you can do with regular expressions, and in your project, I'm not sure, but probably that would be quite reasonable to imply, because if you count some particular parts of speech or some particular named entity recognitions, that might give you more detailed, more accurate results. So with regular expressions, you can do part of speech tagging, but again, it is a bit clumsy if we search for all the parts of speech, but it might be worth doing if we need some particular patterns, like for example, searching for nouns. So here is my sentence. So I split it into tokens, and then I do post tagging to the words, but as it is regular expressions, then if the article is not in the list of patterns, it would tag it as unknown, but if I had the pattern for adjectives, it would find all the adjectives. So I do suggest that if you are not searching just for one part of speech, but you need to do generally part of speech tagging for the whole corpus, then it's quite reasonable to use Spacy library mentioned in the previous lecture, which is a bit more sophisticated than NLTK. It should be installed onto Google Colab. And then after importing it, you can do post tagging with it for all the tokens. Sorry. And here is the result. So you get not only the parts of speech, but also you get their proper names mark or sign for the words that should be processed as a named entity recognition task further. So part of speech tagging, once again, normally it is done even at the pre-processing stage. In your case, you might just look for some particular parts of speech with regular expressions, then you just choose the parts of speech here and set them as patterns. Or if you are interested in analyzing the whole document or the whole corpus, then you can use Spacy to do part of speech for the whole thing. back to the Russian language. If you once analyze a corpus in Russian, then better to use Russian libraries like PyMorphy, for example. That would give you better and more accurate results. So here is the interpretation of the abbreviations for different parts of speech. And as for named entity recognition, as a task in natural language processing opposed to classification, it means that modern transformers try to analyze each particular token or word, figuring out all the sides of its meaning. However, initially, named entity recognition is a kind of the second step to part of speech tagging, because all proper names tagged like this here, Hotel California, yeah, is tagged as a proper name, can be classified again, can be analyzed, or whether they are organizations, dates, names of people, and so on. Again, named entity recognition task, like part of speech tagging, can be done with spaCy. And here we have a sentence about Apple, and quite easily it would figure out that it deals with the name of the company here, not just with the fruit. From the context, and here is the result that it gives the classes of the proper names to all the proper names in the text, sorry. And so that might be, again, reasonable for you, because if you figure out, if you do this named entity recognition task with your corpus, then you can figure out some names that are quite frequent, perhaps not of the first 10 or 20 most famous researchers, but somebody who is kind of new to the sphere. Or you can figure out something else, especially if we speak about humanities. We can take into consideration the geographical names or the names of some events or whatever. So named entity recognition task is additional to your project. You can process it, deal with it if needed. You can try it out and see whether it gives you some results or not. Another library to be discussed today, in addition to NLTK and spaCy, is GenSim, which we will use for the topic modeling task. You remember, probably, that in one of the lectures, again back when we discussed large language models, we mentioned latent semantic analysis, just to work with that matrix of terms and documents. The next step of it is LDA, so latent allocation, the objective of which is to identify the topics of the documents in a corpus, in a data set. So here, if you wanna, you can try to figure out the topics for particular articles, for groups of articles within your data set. And to do this topic modeling task based on GenSim, we will import the library, then use some particular modules of it. Obviously, it's important to remove stop words. And mind that here, of course, to do some topic modeling, you can either work with sentences, so then it's quite reasonable if you want to work with your huge TXT document, then it's quite reasonable to tokenize it as sentences and then to figure out topics per sentences within this huge corpus. Or you can upload the corpus as separate documents, which you probably still have on your computer. And then, but you need to have them in TXT, and that might be time consuming to convert the articles, each particular article into TXT. So probably, in fact, in practice, if you want to do some topic modeling task, it's reasonable to tokenize the text, the whole TXT document with sentences, and then to do the topic modeling task according to all those sentences. As a result, you would get the scores per most frequent topics mentioned in the corpus. So it is kind of the next step to the frequency, to scoring the frequency. The second variant in terms of text analysis that you can do, again based on sentence tokenization, is sentiment analysis. So once again, sentiment analysis is one of the basic NLP tasks for today, and normally it is used to analyze positive and negative attitudes in some reviews. But of course, if we deal with some texts, we also can kind of score the tone to figure out the attitude to some scientific theories or whatever. Usually, sentiment analysis is processed according to the Likert scale, which has 5 kind of levels of attitude, from extremely positive through positive, neutral, and negative to extremely negative. So something that we normally have on all the questionnaires. And so the Veda and text blob libraries are used for, I would say the Veda module, are used for processing to deal with sentiment analysis. So here I share with you NLTK code based on the module of Veda lexicon that helps us process sentiment analysis concerning, again, sentences, particular sentences from your huge TXT document. Again, you can either work with particular articles, but that is time consuming because you need then to convert each particular article into TXT, or just tokenize the whole corpus by sentences, and like with topic modeling here, evaluate the tone of it. And the results would be like this. So you would figure out whether some particular statements that are frequent are positive, are regarded as positive, negative, or whatever in your corpus. You can even combine those two tasks, because if you figure out some particular topics, you can then measure the sentiments according to those topics. But this is just some deeper research within this project. Finally, the third variant of text analysis that you can perform is based on vectorization techniques, and this is clustering. So you can, again, dealing with sentences within your corpus, you can use sklearn framework to cluster the documents or the materials in your corpus. Here, if you deal with clustering, I do believe still in a position to the first two tasks that will make more sense if you compare a few documents. But even if you take just a few articles from your whole corpus and then do clustering on them, that might give you some, again, data on whether the topics are described the same or different way in different articles in different various documents. So these are the main three routes how to analyze the text in your corpus. So either topic modeling or sentiment analysis or clustering, from which I would say that it's better to follow this lecture, so starting with part of speech tagging, then doing named entity recognition, especially for humanities, and then proceeding with topic modeling. And you can stop with this, because if you figure out some frequent names or frequent parts of speech which are of interest for you, that would be already quite enough. Or perhaps in some disciplines, it would be quite enough even to analyze the formulas with regular expressions. That would give enough data for future analysis, for further analysis. However, if you want to go deeper into text analytics, you can do some sentiment analysis at least, or even proceed with clustering. Of course, as vectorization techniques are mentioned here, with the most frequent bigrams or unigrams, you can also use the models that were mentioned before in the course and analyze those terms, for example, with the glove model and with its corpus as well. So all those stages would be described once again in the task for you to figure out what you can use. You're welcome to enlarge and evolve that analysis if you are competent at something else, at some other more sophisticated techniques. But this is the basics which is needed for the task to be submitted. However, that is not the final stage of this project, because next class we will discuss with you some corpus managers that help us without any code, without programming, to analyze the same corpus. And you will further compare the results that you get in such a flexible way here on Google Colab with the results that you can get from those corpus managers, from that software. And finally, during lecture 10, I will share with you some instruments, some tools which help us visualize the data that you get from that text analysis. In fact, that would make, so the project includes the materials from the lectures from 7 to 10, and those tasks are aimed to do your project step by step. As for the last two lectures, they would just deal with some other topics for you to get acquainted with, and you will then have some time, 2 more weeks, to complete your project before the credit. And as for today, as we had 2 lectures in a row, probably the task would be, you will have just one task which includes both pre-processing and analyzing, and you will get double point for it, yeah? The same points as for 2 tasks, okay? So when the platform is fixed, you will get notification in Telegram, and so you will have the opportunity to submit the task. Nevertheless, you have the general idea of all the libraries that we have already discussed with you. So working with the Jupyter notebooks, you can already process and analyze your corpora, but then you will just submit it when the site is available. Once again, I'm sorry, it's not in my hands to fix it, but the guys there are dealing with it. Any questions? Then thanks for surviving the second short lecture, and see you next week. Bye-bye.